WireGuard is a marvel of cryptography. If you need to secure a one-to-one connection between two machines, it is effortlessly simple. But the math gets brutal when you try to scale it across an entire fleet. Connecting 10 developers to 10 servers doesn't mean 20 connections. It means hundreds of overlapping tunnels, and the geometry quickly spins into a chaotic web. Every single time you add a machine, you have to generate a new public key, track down a dynamic IP address, and manually update the configuration files on every other device in that network. And if just one of those laptops reboots or changes its network, the static configurations of the entire fleet are suddenly out of date, breaking active paths across the board. WireGuard perfectly solved the security layer of networking, but it left a massive, unsustainable vacuum in the management layer. The industry reacted to this scaling nightmare in the most predictable way possible, surrendering network management to third-party SaaS coordination servers. Instead of direct peer-to-peer connections, your infrastructure is reorganized into a hub-and-spoke model, where a corporate broker intercepts and dictates the traffic paths between your own private nodes. You are trusting a hosted controller to govern your internal infrastructure. If that centralized broker gets compromised or goes offline, your entire fleet is exposed or stranded. A network cannot claim to be truly zero trust if an external third party holds the ultimate authority over who connects to what. This is where wgmesh comes in. It's an open-source tool that replaces the central server entirely, relying instead on algorithmic discovery to build the network. You generate a shared secret, hand it to a new machine, and run a single command, wgmesh join. Behind the scenes, the network organizes itself using a distributed hash table, or DHT. Much like how torrent seeders operate without a central directory, these nodes use the DHT to autonomously find each other over the public internet, mapping out the topology on their own. By combining a shared secret with decentralized discovery, the network governance is pulled away from external corporations and handed directly to the machines themselves. Discovering another machine is one thing, but actually connecting a remote laptop to a home server is difficult when neither device has an open public firewall port. This is solved through NAT traversal. wgmesh runs persistent keep-alives, actively punching tiny holes through strict network barriers to establish direct lines of sight. Once successful, it dictates the most efficient routing path. Traffic flows smoothly between private and public endpoints without bottlenecks. Every device gets a permanent, stable mesh IP. Its physical location in the real world becomes completely irrelevant. Traditional network updates come with a massive penalty. Adding a new device usually means taking the network interface down and bringing it back up, which severs every active connection in the process. wgmesh avoids this by using state reconciliation, or route diffing. It constantly compares the current configuration of the routing tables in place. The end result is a continuous loop that autonomously updates, heals, and expands the network with zero human interruption. In practice, this means you can expose a local database or a Kubernetes pod to a remote team without ever standing up a traditional VPN server. What used to require agonizing hours of manual key exchanges and endpoint tracking can now be deployed across complex site-to-site architectures in minutes. And if you require strict deterministic control over your environment, wmesh still offers a centralized mode, letting administrators push topology changes across the entire fleet via SSH from a single state file. It bridges a crucial divide, giving you the zero-friction automation of a SaaS product alongside the uncompromising security of self-hosted infrastructure. Maintaining a secure network no longer requires choosing between hours of manual configuration or handing control to a third-party service. By distributing the discovery process across the nodes themselves, the infrastructure becomes self-managing, removing the coordination server as a single point of failure. To see how this autonomous discovery changes your deployment workflow, visit the wmesh open source repository and build your first decentralized mesh.